Hi everyone. So in this video we'll be discussing some practice problems that are based on the phenols. Okay, we have completed the phenols portion. Means we have completed the introduction part and the preparation and chemical reactions part of this portion. And now we'll be discussing some problems based on this particular topic. Okay. So let's first take the example. This is the first example that we're taking. So in this reaction we have to predict the product A and the product B of this reaction. Okay, we have an intermediate product A, we have to predict that product, and then we have to predict the product B of this reaction. So if we try to look at the substrate and the reagents that are used in this reaction, so this is the haloarine, and this particular haloarine is the chlorobenzene. So chlorobenzene is reacting with sodium hydroxide base, and we are giving the heat to this reaction. Okay, so if we recognize these reagents and the substrates, then we'll come to the point that this reaction will be recognized as the Dow process. It is the Dow process, because in the Dow process we react the haloarine with the sodium hydroxide, giving it the heat to this reaction mixture. Okay, and in this reaction, this process is actually the process of formation, is the method of formation of the phenol. So obviously the final product is going to be the phenol in this reaction. So the final product B is going to be the phenol, and the product A is the intermediate product. And if we remember the mechanism of this reaction, if we remember the reaction, then in the first step of the reaction we are forming we'll be getting the what you call as, in this reaction we'll be getting A will be the phenoxide ion. Okay, this will be the phenoxide, and this will be the sodium phenoxide will be the product A in this reaction. Okay, this on acidification with the acid will be getting the product B. Okay, with acidification will be forming the sodium chloride, and this proton will be attached to the oxygen, and the final product, that is product B of the reaction, will be a phenol. We'll be getting a phenol in this reaction. So this is the phenol that we get. Okay, so just what we have to do, we have to remember the substrate and the reagents that we use. Then we can directly predict, without going to the mechanism, we can directly predict the reaction product in any type of the reaction. Okay, so this, we know that the haloarenes react with the sodium hydroxide with the base, and this is the Dow process, and the Dow process is a method of preparation of the phenol. Okay, so the product A will be the phenoxide, sodium phenoxide, and product B will be the phenol, the final product of the reaction. Okay, so let's take the next example. Okay, so we have a benzene. In the first step, the benzene reacts with this alkene. Okay, we have an alkene, and the reaction of benzene with alkene in the presence of AlCl3. In the presence of AlCl3 we are doing this reaction. So the next step is the oxidation step. This is the oxidation step. Okay, and the final step is the protonation. So when benzene reacts with alkene, so this is the first step of this reaction, is the Friedel-Crafts alkylation. Friedel-Crafts alkylation. This is the Friedel-Crafts alkylation. And in this reaction we are getting two products, product A and product B. So we have to predict both of these products. But before going into the details, into the mechanism of reaction, we don't need to go into the mechanism because we have already discussed it. We have to just remember the substrate and the type of reagents that we are using in this reaction. Okay, so if we look at the substrate, we have benzene that in the first step reacts with an alkene in the presence of AlCl3. That is, in the first step there is the Friedel-Crafts alkylation reaction taking place. Okay, that means this alkene will be substituted on this benzene ring. Okay, and in the subsequent steps will be doing the oxidation of that product, and we'll be getting the proton, and final product will be doing the protonation, and we'll get two products in the reaction. So the product A and product B, we have to predict these two products. Looking at this reaction, we can guess that this is a cumene process. This is the cumene process for the preparation of phenols. Okay, so in the cumene process, what actually we have, the cumene is oxidized. Okay, that's oxidized, which on subsequent protonation gives us the phenol. And phenol, in this reaction we get two products. In cumene process we get two products. One product is phenol, this is the main product, and in addition to this we also get acetone as a byproduct of the reaction. So that is what actually we have, these two products. What actually we have to do is we have to recognize the substrate and the reagents. So we have not been directly given the cumene. What actually cumene is? Cumene it is isopropyl benzene. Okay, it's isopropyl benzene. This is benzene, and to this we have this propyl. Okay, so this is isopropyl benzene, this is the cumene. Okay, so in this reaction we have not directly been given the cumene. Okay, the actual reaction is that this cumene reacts with oxygen, and in the next step it will be protonated. Okay, in the first step it is oxidized, second it's protonated, and we'll be getting these two products A and B, that is acetone and phenol. But in this reaction we have not been directly given the cumene, but we have been given the benzene. In this reaction, the benzene first reacts with the with this propene. Okay, this is propene by the Friedel-Crafts alkylation reaction, and in this reaction we get this cumene. Okay, and this cumene on reaction with oxygen, if you remember, we get an intermediate product which looks somewhat like this. This is propyl group, and we have this. Okay, which is called as cumene hydroperoxide. Okay, this intermediate product, which on subsequent chains finally gives us the phenol as a product. So we have to recognize the reagents and the substrate, and as we know, in the cumene process we get two products. One is the phenol. So the product A in this reaction will be phenol, and the product 2 will be the acetone. This is the acetone. Okay, this is acetone, and this is the phenol. These are the two products of the reaction. Okay, we have to remember all these things. These things have to be remembered, the reagents and the substrates and their products. Okay, this is all that we have to do. In each and every case we do not need to remember the mechanism, because in exams we don't have in competitive examinations we don't have the time to deduce the mechanism and find the products. Okay, next we have this reaction. We have this is the primary aromatic amine. So we react this primary aromatic amine with the reagent, that is NaNO2, in the presence of HCl, which is called as the nitrous acid. This is nitrous acid. Okay, so the reaction of primary aromatic amine with nitrous acid in the first step, and in the second step we are hydrolyzing it. Okay, this is the hydrolysis of the product that we'll be getting in the first step. So this is again, if we remember, this is one more method of preparation of phenols, and this is the preparation from diazonium salt. So in the first step of the reaction, that is the reaction of this primary amine, aromatic amine with the nitrous acid will be getting the intermediate product, when this primary amine reacts with nitrous acid, then we'll be getting the diazonium salt. Okay, this is the diazonium salt. Actually the diazonium salt is hydrolyzed to phenols, but here we are first preparing the diazonium salt. So the diazonium salt is prepared by reacting the primary aromatic amine with the nitrous acid. So we'll be getting the diazonium salt. This is diazonium salt, can be written as this. We have and chlorine, positive charge on nitrogen, and we have negative charge on this chlorine. So this is diazonium salt, and this particular diazonium salt is known as, named as benzene diazonium salt. Okay, so in this reaction, we are in the first step, we are getting this, and the subsequent hydrolysis, that is reaction of benzene diazonium salt with water in presence of heat, we get phenol as the product. Okay, so the reaction product in this reaction is the phenol. All we have to do is to recognize the type of substrate and the type of reagents that we are using. Okay, now taking the next reaction, we have a benzene. In the first step, it reacts with sulfuric acid, and then in the second step it reacts with the base, that is sodium hydroxide, and finally we are doing the protonation in this reaction. So again we have to predict the type of product that we'll be getting in this reaction. Okay, in the first step, the benzene reacts with sulfuric acid. And actually in presence of sulfur trioxide. Okay, so 3, and this is actually known as the oleum. Okay, so it's first converted into benzene sulfonic acid. So this will be converted into benzene sulfonic acid. This is benzene sulfonic acid, which on reaction with sodium hydroxide at high temperature, we get the sodium phenoxide. Okay, we get the sodium phenoxide. We get the sodium phenoxide in the reaction. Okay, that is the second step of this reaction, which on protonation, that is the third step, which on protonation gives us the final product, that is the phenol. Okay, this is the phenol. So this is the product of this reaction. We'll be also having some byproducts, but the main product is this is the phenol. Again, this is the method of preparation of phenols from benzene sulfonic acid. So first benzene is converted into sulfonic acid by reacting it with the oleum, that is with different concentrations of sulfuric acid and sulfur trioxide. Then the reaction with sodium hydroxide gives us the sodium phenoxide, which on protonation gives us the final product, that is the phenol. Okay, now we have the reaction. We have to arrange these in the increasing order of their acidity. Okay, so acidity is the ease with which this proton is released in these compounds. The compound will be more acidic in nature. Okay, so first of all, we recognize this is phenol, this is nitrophenol, this is the carboxylic acid, and this is the phenol, and we have the methyl group attached to this phenol at para position. Okay, so this is the cresol. We have to arrange these in the increasing acidity order. So first of all, in increasing, we have to write the compound that is least acidic in nature. So we'll write this as compound A, B, C, and this is compound D. We have to arrange A, B, C, D in the increasing acidity. So first of all, we'll look at these compounds and find which is least acidic of these. So if we look all of these, the phenol is having a particular acidity, any electron withdrawing group or any electron donating group is going to alter the acidity of this particular phenol. So if electron withdrawing group is attached to the phenol, then that will increase the acidity of the phenol, and if electron donating group is present on this ring, that will decrease the acidity. Okay, so if we look at the product D, we have a CH3 group attached to the ring, so this is going to decrease the acidity of the ring, because it is having the plus I effect. Okay, plus I effect is going to decrease the acidity of the compound. So the least acidic of all the four will be the compound D in this reaction. Then the nitro group is going to increase the acidity of the compound of the phenol. So it will be more acidic than the phenol itself. So next will be the compound A, that's phenol, that will be followed by the nitrophenol, and of all these, the most acidic is the carboxylic acid. Okay, that is the compound C. We should remember this, that carboxylic acids are more acidic than the what you call as the phenols. Okay, why? Because we have a conjugation when this carboxylic acid loses the proton, then again there is a lone pair of electrons on this oxygen. It's going to hold it more easily. Okay, the negative charge is easily held on the oxygen. It has the capability of holding the negative charge, so it will easily hold it, and there will be conjugation between these two oxygen atoms as compared to the phenol ring. So this will be the increasing order of the acidity. The most acidic will be the carboxylic acid, and least acidic will be the cresol, that is the methyl substituted phenol. Okay. Another reaction, we have a phenol, and it's having two types of reagents. One is the acid chloride. This is acid chloride in presence of base, and this is acid anhydride. This is acid anhydride in presence of base. Okay, so if we recognize the reaction, this is the esterification reaction. Both of these are esterification reactions. Okay, these are esterification reactions, and in the two reactions we are going to get the esters, but we should remember that in this reaction, when the phenol reacts with acid chloride, we get the ester, and the ester will be like this: CH3CO. Can write this in the expanded form. That this is the phenol, and we have OC double bond OCH3. Okay, so this is the ester that we get when the phenol reacts with acid chloride, and when the phenol reacts with the acid anhydride, again this is esterification, and we have two products in the reaction. One is the ester. The same ester will be getting here. We'll be getting the same ester. You can also write it like this: double bond O CH3. In addition to this ester, we also get the carboxylic acid. We get CH3C double bond OH. This is the carboxylic acid. So these are the two products when the phenol reacts with the acid anhydride, and there is one product then when the phenol reacts with the acid chloride. So this is the ester, and this is also the ester. Okay, so this is the esterification reaction of phenols. Next, we have to predict the major product of these reactions. The phenol reacts with dilute HNO3, dilute nitric acid, and in another reaction, the phenol reacts with the concentrated nitric acid. So this is the substitution reaction, aromatic substitution reaction, and this particular reaction, both of these reaction, is the nitration reaction. This is the nitration reaction, and there is, we know, in the electrophilic substitution reactions, there is a formation of an electrophile that attacks on the or we can say the ring attacks on that particular electrophile, and that's substituted to the ring. Okay, so in this reaction, in the nitration reaction, we have the electrophile that acts in this reaction is the NO2 positive. Okay, this is the electrophile that is this NO2 group, this nitro group will be attached to the ring. So when the phenol reacts with dilute HNO3, when it reacts with the dilute HNO3, we get two types of products in this reaction. We get two products. One is the ortho product, that is this NO2 is substituted at the ortho position of the phenol ring, and another reaction, and that's another product will be the para product. This is the para product in which the NO2 group is substituted at the para position of the phenol ring. So we have to predict the major product. The major product of the two will be the ortho product. This is the major product of the reaction. Why? Because it is more stable. Okay, there is more negative charge on this ortho carbon. Therefore this easily is attached to this particular carbon, ortho carbon, and also the stability is increased by the hydrogen bonding between the nitro group and the hydroxyl group of the phenol. So this is the major product of the reaction. And when the reaction is with concentrated phenol, in this we get the tri-substituted product, that is we have NO2 at two ortho positions and also at the para position. This is called as the picric acid. This is the picric acid, and this is the only and it's the only and the major product of the reaction, only product of the reaction. Okay, let's look at another question. Again we have phenol, and the phenol reacts with bromine. Okay, we have two pathways in this reaction. One is when bromine reacts in the presence of water, and the water here is a solvent, and another pathway is that bromine reacts in the solvent, that is we have dichlorocarbon, or we have CS2. This can be as the what you call as the solvent in the reaction. So these are the two pathways that we're supposed to follow. This is actually CCl4, okay, carbon tetrachloride. Okay, so we have these two pathways. The phenol reacts with either when the phenol reacts in this pathway, that is we have three bromines in the presence of water. So we have to predict the reaction product. Okay, and in this case also we have to give the reaction product. Again, this reaction is the bromination reaction. This is bromination reaction. Recognizing the substrate and the reagents, we conclude that these both reactions are the bromination reactions. Okay, so again the reaction is its electrophilic aromatic substitution reaction, and the electrophile in this case will be the bromine. Okay, so the bromine is substituted into the ring of the phenol. Okay, so in this pathway, because we are taking water as what we call as a solvent in this reaction. So in this reaction, the first we get the phenoxide ion. Okay, we get the phenoxide, which is very reactive. So in this case we get the tri-substituted phenol. Okay, we get tri-substituted phenol, that is we have two ortho positions are substituted by phenol, and the para position is also the two ortho substitutions are ortho positions are substituted by the bromine, and the para is also substituted by the bromine. So we have this tri-substituted phenol we get in this reaction if the reaction follows this pathway. If we change the solvent and we take CCl4 or CS2 as the pathway, this question is asked many a times, because this is a little bit conceptual question. So in this question we get in this pathway we get two types of products. One will be the phenol that is ortho substituted, and another will be the phenol that is para substituted phenol. Okay, so this through this pathway we get monosubstituted phenol, and via this pathway we get the tri-substituted phenol. Okay, we can subsequently name these products according to the IUPAC nomenclature. So these are the products of these two pathways of this reaction. So both reactions are bromination reactions. Okay, So if we are given with these reagents, then the product will be this, and if we are given with these reagents, then the product will be these two will be the products. Now we have phenol, and phenol reacts with sulfuric acid. Okay, we have two pathways. In both the pathways we have H2SO4 as reagent, but we have a difference of temperature. In one pathway the reaction takes place at the what you call as 25 degrees Celsius, and other pathway the reaction takes place at the 100 degrees Celsius. So there is only difference of temperature. We are increasing the temperature in one case and decreasing the temperature in another case. What the impact of this temperature difference is that at lower temperature we are getting the ortho substituted product. Okay, we are getting the ortho substituted product as major product. This is the major product. And in the higher temperature we get the para product as the major product. Okay, so these reactions are again the electrophilic aromatic substitution reactions. And if we remember, this is the sulfonation reaction. This is the sulfonation reaction. In this reaction SO3H positive is being this is being substituted to the ring of the phenol. Okay, this is the electrophile in the reaction. So there's just the difference of temperature. If we are given with this temperature and we have to give the major product, then the ortho product will be the major product. And if we are giving with this temperature, then the para product will be the major product of the reaction. Now we'll take these reactions. We have phenol that reacts with sodium hydroxide in the first step, then with the carbon dioxide, and then last it is the protonation. And if we remember, this is a very famous reaction, that is the coal-base reaction. Okay, just recognizing the reagents, because it's the carboxylation of the phenol taking place. So this is coal-base reaction. Okay, and we know that in Golbe reaction we get what is the product. That is the more very famous product, that is salicylic acid. Salicylic acid will be the product. So in the first step of the reaction we will get the phenoxide ion, and in the second step this carbon dioxide will be this will react with the phenol, and we'll be getting a intermediate product, which on protonation gives us the what you call as the salicylic acid. That is, salicylic acid can be written as this is OH, and then we have COOH at this position. Okay, so this is the priority group in this compound. Okay, so this is 2-hydroxy compound. Okay, this is position 1, this is 2 position. So at the 2 position the compound is substituted. Okay, so this is the salicylic acid, and the reaction is Kolbe reaction. So we are just recognizing the reagents and the substrate, and we can predict the product of the reaction. Same questions can be framed in different ways. Maybe we are given with the substrate and we are given with the product, and we have to answer the types of reagents that we'll be using in this transformation. Okay, so there we have different types of questions that can be framed on any type of reaction. Okay, so this is the most general reactions that we are giving here in our examples. So this is the Kolbe reaction. We are getting the salicylic acid. This is another reaction, very famous reaction again, that is the Remer-Tiemann reaction. Okay, so we know in the Remer-Tiemann reaction we get the salicylaldehyde as the product. Okay, we get salicylaldehyde as a product, that is the phenol. On this phenol we have the aldehyde group is attached at the ortho position, and also a very little amount of product is the para product. Okay, this is the para product. Again, this will be the major product of the reaction, and this will be the minor one. Why? Because this is more stable due to the hydrogen bonding, and also this position is when we look at the at the what you call as the resonance structures, then the more this carbon is having more negative charge. That is why this product is the major product. The ortho product is the major product of the reaction, and this product is called as the salicylaldehyde, whatever the spelling. Okay, so these are the products of the reaction. So the reactions that we have shown, that examples we have taken, are actually the direct reactions. Just for the revision, we should recap from these reactions, and in the upcoming videos, we'll also try to solve some more conceptual problems based on this particular topic.